In this video, we are going to learn how to properly choose a solvent for recrystallization. In order to choose an appropriate solvent, that solvent must satisfy several parameters. First, the compound being recrystallized should have high solubility when the solvent is hot and boiling, and should have very low solubility when the solvent is cold or at room temperature. Secondly, any impurities should be either completely soluble in the solvent at any temperature or completely insoluble at any temperature. Third, the solvent being used should not react in any way with the compound being recrystallized. And finally, the boiling point of the solvent should be below the melting point of the solid. So in this demonstration, we are going to use the solid compound fluorine, and please note this is the organic compound fluorine and not the element fluorine, and three different solvents, toluene, water, and methanol, to gauge their appropriateness as a solvent for this recrystallization. So first, I'm just measuring out a small amount of fluorine into each of three test tubes, and each test tube will get one of the three solvents to test for solubility purposes for recrystallization. So in our first trial, we will start by using toluene. Toluene, being an aromatic hydrocarbon, is a highly nonpolar solvent. So to my first test tube, I will add a small amount of toluene, and we'll see what happens at room temperature. If the fluorine is completely soluble at room temperature, then we know that it's a poor choice for solvents. If it's not completely soluble at room temperature, then I'll heat the sample up and see if it dissolves when it's hot. So we now add a small amount of toluene to our test tube, and as we can see, it's already starting to dissolve the fluorine. And as I shake the test tube a little bit, we can now see that the solvent has, or the solute has, completely dissolved in the toluene. Since the fluorine has completely dissolved in the toluene at room temperature, that means the fluorine is too soluble in toluene, and we've now chosen a solvent that would be a poor choice for recrystallization, because we will not be able to get the fluorine to crystallize back out of solution. So from here, we're going to switch to a more polar solvent, in this case a very polar solvent being water. And now as I shake this test tube, we can see that the fluorine is not dissolving at all. So far this is one possible solvent for this recrystallization, because that's what we want, is we want very little solubility at room temperature. Now the second part is when the water is boiling, we do want it to be highly soluble. So I'm going to put that in my sand bath, which I've preheated, and see if when it comes to a boil, if it has dissolved or not. While that's going on, I'm going to start my third trial, and this one will use methanol. So again, we'll add a small amount of methanol to this sample, and as in the case with water, we can see that the fluorine has not dissolved at room temperature. So I will also add the methanol sample to the sand bath and let that one come to a boil. Now we can see they've both come to a boil, and we have two very different results. In the case of water, even in boiling water, the fluorine has still not dissolved. So since the fluorine has not dissolved at high temperature, that also means that it's a poor solvent. In the case of methanol, we can see that some of it has dissolved. And so by increasing the temperature, we've increased the solubility in methanol. Now we haven't dissolved at all, so I've now added a small amount of additional methanol to see if that will completely dissolve all of the fluorine. As we look more closely, we can see that almost all of the fluorine has dissolved, and so again I'll add a small amount of methanol and put it back in our sand bath until it boils. Now we have to be careful when we're boiling off solvent, because as we boil off solvent we also reduce the volume of solvent. So if we boil it for too long, we'll decrease the amount of solvent, and then we may need to add more to make up for what has already boiled off. And so that's what's happened here, is I let it boil for too long and we ended up decreasing our amount of methanol. But now that I have a sufficient amount of methanol and I brought it to a boil, we can see that it has completely dissolved. So in terms of temperature, we have found that it's good at room temperature, it's good when it's boiling. So now we're going to cool it to room temperature and then cool it in an ice bath, and our final test is to see if our fluorine will successfully crystallize once the solution has cooled. Now that we've allowed our solution to cool to room temperature, we can already see that some of the fluorine has started to crystallize out. Now that we're at room temperature, we can place it in an ice bath and see if we get further crystallization. Remember, you do not want to place your hot solution and hot glassware directly into the ice bath, because you may get poor crystallization as well as break the glassware. Once we've taken it out of the ice bath, we can see that we have a significant amount of crystallization, and so we can see that in methanol our fluorine was not very soluble at room temperature, was highly soluble when the methanol was boiling, and has now crystallized very nicely when we've cooled it in an ice bath. So this means we found that methanol is a suitable recrystallization solvent for fluorine.